Outline synthetic pathway. Okay, so how to answer this kind of question? Okay, so first of all, let's us have a look at the question. It says here, propose a 2-step synthetic pathway to prepare from CH3CN. Okay, so the first thing that you must know is that it started from CH3CN, and then finally we will get CH3CO and CH2, CH2, CH3. Okay, now some students, they will say, what they will do is they draw an arrow here, and then they start to have the synthetic pathway. Okay, for example, I put A, and then I put B, and then I get the final answer. Okay, this kind of writing method is incorrect. Okay, because it says here 2 steps, means that nitrile compound cannot be straight away convert to amide. Okay, so this, if you write this arrow, then the whole thing is wrong. Okay, however, you can write like this: A to B to C to D. Or you can just write A, B, C. Okay, either one. Okay, now let us look at the requirement of the question first. Okay, so the first step is, when we look at the question says that it is only 2 steps. Okay, what is the meaning of 2 steps? Okay, so if 2 steps, 1 step, 2 step, 3 step, 1 step, 2 step. Okay, so this is 2 step. So means we are going to use 2 times reagent. Okay, now we start again. Okay, so we have CH3, CN, and then the final product becomes CH3CO, NH, CH2, CH2, CH3. Okay, so first of all, let's look at some important thing. Okay, you can see that there's similarities here. Okay, and then we know that CONH is amide, and then we know that this is nitrile. Okay, so means that we need to prolong the or extend the product, okay, to add 3 more carbon and also 1 nitrogen and also oxygen. So how to do it? Okay, so let's look at this. Okay, maybe you can remember from amine, okay, from amine, nitrile can go and undergo reduction and become amine. Okay, now another one is nitrile compound can undergo hydrolysis, becomes carboxylic acid, and then when react with ammonia or amine, it will produce amide. Okay, so we can see here what we want is amide. Okay, so means our answer is already in this my map, that is carboxylate. Okay, now we go back here. Okay, so what we do is, first of all, we start with the nitrile compound, undergo hydrolysis, becomes carboxylic acid. Okay, so when it becomes carboxylic acid, it looks like this: CH3, C double bond O, OH. Okay, now our final product, okay, we need to add in NH, CH2, CH2, CH3. Okay, means we need to add, because it undergoes condensation, CH2, CH2, CH3. Okay, so this part is eliminated, and then we will get our amide. Okay, but remember, you must put in heat, otherwise you will get salt first. Okay, so does this fulfill our requirement for our question? That is 2 step. Okay, so this is first step, and this is the second step. Okay, now we go to next example. That is another famous one, that is the Grignard reagent. Okay, here it only says show the synthetic steps to prepare alcohol via Grignard reagent and propanol. Okay, so what we do here is, let's look at what we have. First, propanol. Okay, propanol. And then here it only mentioned Grignard reagent. Okay, you can use MgCl or MgBr. Okay, usually students will start from here. That is, this is the Grignard reagent. Okay, but you have to remember Grignard reagent can only be prepared by in situ. So that's why we have to start from haloalkane and react with magnesium in dry ether. Then we can get our Grignard reagent. And then when it react with propanol, we will get our answer. Okay, so how do we answer this kind of question? Okay, so first of all, draw the final product, that is COH put on top. Okay, then we have CH3, here also CH3, then another here is CH3. Okay, and then just now we already said that it is propanol, right? Okay, if propanol, I straighten it. Okay, if I straighten it, this is also propanol. So this part, double bond O will becomes OH. So our Grignard reagent will be only CH3 MgCl. Okay, so remember the points that I want to highlight for synthetic pathway is, remember, don't put straight away arrow from the reactant to product because it involves more than one step. Okay, other than that, just remember to put all your reagent conditions on the arrow. That's all for this part.